Today we're looking at section 8.2, confidence intervals for a population mean when the standard deviation for the population is unknown. Remember that last time we constructed a confidence interval by expanding around the point estimate, which was the sample mean. But we assumed, maybe unrealistically, that the population standard deviation sigma was known. So let's look at the case where sigma is not known. Instead, what we do is we find the sample standard deviation, S. But a lot of our problem-solving process is similar, right? So once again, given a large sample size with mean x bar and sample standard deviation, which we're going to call S, that's just to be clear, that's an S, we create a whatever percent confidence interval as follows. First, find the standard error, which we denote SE. And it's the same thing as before, standard deviation over root n, but we're using S this time, right? Because we don't know what sigma is. Then we decide on the appropriate level of confidence, which is often 95%, but it could vary. Often the problem will just give it to you. Anyway, after finding the degrees of freedom, what's going on here? Would you note this DF? We're using a distribution called the student's t distribution, which is different from the normal distribution. So we can't use z values anymore. So we consider something called the degrees of freedom, which is a fancy way of saying n minus 1. And we find the corresponding t value. And the book uses t sub alpha over 2. I'm just going to use t, just because I think it's less confusing. But anyway, I'll show you how to do that in a sec. Then you're going to find the margin of error. This should be familiar. And this is going to be that the margin of error is, so instead of z, it's going to be t times s over root n, right? Or maybe I should write it like this. T times your standard error, which is t times s over root n. Okay? So it's a similar margin of error formula. You're using t instead of z and s instead of sigma. And then this should be familiar too. X bar minus the margin of error to x plus the margin of error, right? That's our whatever percent confidence interval, which means we are whatever percent confident that the true mean, not battery life, get rid of that nonsense, is within our interval. In other words, if we were to do this over and over and over again, then whatever percent we decided of our samples and our intervals, really, should contain the population mean. Maybe just to be clear, this is not samples, this would just be intervals. All right, let me do number 32 by hand using the chart, and then all the others I'll do with Minitab. It's nice that they don't even give a word problem. They just give us the data, right? No need to parse anything, no need to interpret anything. So construct a 98% confidence interval. So if we're not using Minitab, what we can do is we just want to calculate the margin of error by hand, and then add and subtract it from the point estimate x bar. So remember that the margin of error is going to equal, we just wrote it down, right? It's going to be t times the standard error, which is t times s over root n, which is t times, okay, I guess we're just given s, and we're given n. So all that's left to do is to find t. So in order to do this, let's just go to our textbook. So remember that we can find these tables. Whoops, let's see, I might need to zoom out a little bit more. Yeah, so what you do is you scroll to the bottom of your textbook, click tables A2 and A3, scroll all the way down so that we're looking at table A3. And note that here this says degrees of freedom, right? That's what we're looking at. right? So n equaled 44. Now, I don't see 44 degrees of freedom. So what we do is we round down to 40. Even if it were 49, still round down to 40. And then you just sort of keep going. Oh, look, we hit the 98. We hit the 98% confidence level, right? You see that right here? Confidence level 98. And for 40. So it's 2.423. So this is really, you know what? Let me, times this stuff. And if we just multiply that stuff out, what's that going to give us? Let's just use a calculator really quickly. 2.423 times 9.1 divided by the square root of 44. 3.32. I'll just say 3.3 since they give us one decimal, okay? 3.3. Okay. So our 98% confidence interval is 56.9 minus 3.3 to 56.9 plus 3.3. Let me lower that a little bit, just kind of, whatever. It's okay where it is, right? And we'll just say that this is going to equal, if we subtract that, I think we're getting 53.6 to 60.2. Okay? So that's our answer for that. And I just want to be clear, right? 98% corresponds to this value right here. That's what makes it a 98% confidence interval, was the confidence level that we chose. Okay? For part B, right, if our sample size decreased to n equals 30, would the interval be narrower or wider? Well, you could just go ahead and find it, but you shouldn't have to. If we decrease n, the denominator of a fraction, that's going to increase the number. Also, when we take a smaller sample size, we just don't know as much, so we would expect our margin of error to be bigger because there's more room for error. So, more error means a bigger confidence interval. So I said why, but I want you to write it down. Now let's do it the quicker and easier way. Number 33, right? Again, they're just giving us our numbers, so we're just going to take it, right? Construct a 95% confidence interval, right? And then they ask a similar question afterwards. Let's do this in Minitab, right? Try to do this side by side so we can see. Whoops. Okay, so if we go to Minitab, here's Minitab. Get out of this. So what we do is we go to Stat Basic Stats, but we choose one sample T because we're using these students' T distribution. We aren't given a bunch of data points. We're given the summary of the data, which is nice because then we can just go n equals 89, 9.2, right? You see, I'm just copying the data in. No real thought. Leave the perform hypothesis text box unchecked. Now, if they had said like 98, like the previous example, we would change this value, but they didn't, so we're going to leave it. And make sure that mean does not equal hypothesized mean. Do not change the alternative hypothesis. This won't work otherwise. And that's our confidence interval, right? It just spits it out for us. Our 95% confidence interval is, and I'm just copying an answer here. All right, that's the answer. All right. Now, if we increase the confidence level from 95 to 99, would our interval be narrower or wider? Well, if we want to be more confident that the mean is within the interval, we would need to make the interval wider. Again, I just said why. I'd like for you to pause the video and write it down. Let us continue. Now, just a couple of quick theoretical assumptions we need. This is the same as before. This process works only if our samples are random. If there is bias in our methodology, then you can chuck this all out the window. Our samples are also reasonably large, meaning they are greater than 30, right? Satisfy that central limit theorem condition. Or our samples, they can be small, but they need to be from an approximately normal distribution. Now, of course, there are trade-offs from higher confidence levels, right? Higher confidence level means that it reduces the chance that mu is outside the interval, but increases the length of the interval, and hence our uncertainty about what mu actually is, right? Let's do one more quick example. Fake Twitter followers. Just, you can pause the video and read the problem, but what you can get from it is that n equals 46, x bar equals 14.1, and s equals 9.6. Right? That's what we need to know. All right? So it might be a good idea to just write down the data when you get it. All right, so anyway, we're going with this. Construct a 90% confidence interval. Let's just use Minitab, right? We have our data right here. Stat, basic stats, sample T. Again, there. Right, and then here for option, oh no, I didn't want that to happen. Oh, stat, basic stats, there. Try that again. Okay, 46, 14.1, 9.6. Right, now for here, options, and because they ask for a 90% confidence interval, right, see, 90, change that to 90. Leave everything else the same, and we get our answer. Our 90% confidence interval, oh my gosh, is 11.72 to 16.48. Right. And so then, is it reasonable that the mean percentage of fake Twitter followers is less than 10? Note that 10 is not in our confidence interval. So you can interpret the confidence interval as the list of reasonable values, reasonable estimates for mu. So no, it's not reasonable. So that's that. Now, I just want to point out that last video I did mention that we had a formula for, and given a specified margin of error that we wanted, we could find the number of individuals we needed to sample to get that margin of error. We can do the same thing here. There are just two things. Number one, the sample size needs to be over 30. And number two, we are going back to using Z instead of T. And if you think about it, that makes sense because T depends on the sample size. So it's sort of an iterative process otherwise. Anyway, what's the formula? Honestly, I forget. So let's just derive it. We know that the margin of error equals, in our case, it's going to be Z times the standard error, which is Z times S over root N. solve for n. So we have MOE equals z times s over root n, multiply by root n, divide by margin of error. That's a times, by the way, not like a minus sign or something. And then we square both sides to get n equals this stuff squared. And then what if we get a decimal? Well, round up. Every single time. Round up. Even if you get like 34.001, the answer is 35. Otherwise, your margin of error is not going to be big enough. So it's going to wind up being n is greater than or equal to z times s over the margin of error squared. And that's what we've got.